In our last video, we looked at finding inverse functions. Actually, we looked at kind of the concept of an inverse function to try to get a feel for what is meant by inverse functions. And we also looked at the concept of a one-to-one function. In this video, we're going to look at actually being given a function f of x equals something, and then the process for finding its inverse function. Before we do that, I want to kind of review what we talked about an inverse function is. For instance, if I have a function f of x equals x plus 4, if we think about its inverse function, f inverse of x, we're finding the function that takes these values of x, f takes these values of x over here to these values of y. That's what f does. The inverse function is going to take this number and bring it back to where you started, and that's f inverse. So I want you to think about what function would undo what the function x plus 4 does. Go ahead and write that in. And hopefully what you said was that if I have a function that takes a number, for instance, if I start with the number 5, that would add 4, which would give me 9. So we need to find the inverse function that would take 9 back to 5. And that would be the function that takes the number that you start with, the 9, and subtracts 4. We kind of intuitively know that already. We know that if we have addition, its inverse is subtraction. We know some other inverse operations as well. We know that the inverse of multiplication is division. The inverse of the square root is squaring. The inverse of cubing is the cube root. So we have kind of an intuitive idea of inverse operations, operations that undo what a previous operation did. What we're going to look at in this lesson is a step-by-step process for finding an inverse function. Given some function. Our first step is that we have to check that the function given is one-to-one. Remember, we learned in our previous lesson, if the original function is not one-to-one, then we cannot find an inverse of it. Our second step is to replace the function notation, f of x or g of x or whatever it's called, with a y. Because remember, my output y is the same thing as f of x. My third step, and here we're going to remember what we did with those ordered pairs in our previous video. If we wanted to find an inverse function, what we literally did was switch x and y. Flip-flop the x and the y. And that's what we're going to do here to find an inverse function. We're going to switch x and y. And you'll see what I mean by this here in a minute when I do an example. And then, now the y in that relation is my new f inverse function. But we don't normally write a function with the y within the relation. We normally have the y all by itself to one side. So my next step is to solve for y, isolate y, and then that y is my new inverse function. So we're going to replace y with f inverse of x. So the big step here, the big important thing here is right here when we switch x and y. Let's do an example. Let's say that we have the function find the inverse function f inverse of x of the function f of x equals 3x plus 7. Now my first step is that I have to make sure it's 1 to 1. Well, let's think about what a linear function looks like, the function f of x. We have not actually learned how to graph linear functions yet, but we do know from transformations that if I were to graph this function, it would look like my basic function y equals x, this one, but it would be stretched by a factor of 3 and moved up 7 units. So I would have a line that looks something like this. So this is f of x. I wouldn't really even have to know that much about graphing lines at this point. If I were to graph any line at all that was slanty in some way, in other words, not horizontal and not vertical, those kinds of lines that are slanty like that are called oblique lines. So any oblique line is going to pass the vertical and the horizontal line test. So we see yes, this is 1 to 1. That's our first step. Second step is to replace the f of x with a y. So I rewrite y equals 3x plus 7. This function right here, this y that I'm dealing with right here, is my original function f of x. Now we do the big step here. We do the switching the x and the y. So I literally put an x where the y was and put a y where the x was. Now this y is now my inverse function y. But I need to write it as a function, so I need to isolate that y. And I can do that by subtracting 7 from both sides. And now dividing by 3 on both sides. This y is my inverse function. So I can rewrite that as f inverse of x equals x minus 7 over 3. And if I rewrote that in linear form, which we'll talk more about in our next couple of lessons, I could rewrite it as 1/3 x minus 7/3. Let's try another one. And I'm going to go ahead and rewrite my process here. Check it's 1 to 1. Rewrite with a y. Switch x and y. Solve for y. And then rewrite with f inverse of x. All right. Now, let's say that I'm given the function f of x equals the cube root of x minus 5. And what we want to do here is first sketch f of x, and you're going to use transformations to do this. You're going to think about what the cube root looks like, you're going to think about what the minus 5 does, and then draw a sketch of that. Then we're going to find f inverse of x, and then we're going to sketch f inverse of x. And we're going to use that doing transformations as well. So I want you to actually do these steps yourself. I want you to see if you are able to sketch f of x using transformations, find f inverse of x using our process we learned over here, and then sketch f inverse of x. So pause the video, try those 3 steps, or try to do those 3 things, and then turn the video back on. All right, first step here is I am going to sketch f of x. Now, I know that the cube root of x looks like this. I should know that from memory by now. And if you are still struggling with those graphs, you can look back at the earlier video, graphs of basic functions. Then we know that the minus 5 inside of the function means that I am moving to the right 5 units. So this point right here, 0, 0, moves to the right, and then I can reproduce my graph. So that's what f looks like. Now I'm going to do the part where I find the inverse function, f inverse of x. My first step is to check if it's 1 to 1. And if I look at my graph here, I see it passes the vertical line test and the horizontal line test, so yes, it is 1 to 1. So that's my first step. If it is not 1 to 1, I cannot find an inverse at all. Then I'm going to rewrite the function, replacing the f of x with a y. Then I'm going to do the big thing here, the most important thing here, is switching the x and the y. So I put an x in for the y and a y in for the x. And now I solve for this y. So I have to think about my order of operations here. If I'm isolating the y and I have all of this under a cube root, the first thing I need to do is cube both sides. And I'm going to write that as a separate step here so you can see what happens. So if I have x equals the cube root, x equals the cube root of y minus 5. To get rid of this cube root, I have to cube all of that, which means I have to cube that. The cube and the cube root eliminate each other, so I have x cubed equals y minus 5. And then now to get y by itself, I add 5 to both sides. And now this y is my f inverse. So I have f inverse of x is equal to x cubed plus 5. It's important that you work through these steps one by one. Don't try to switch x and y and isolate y at the same time. Think about those as completely separate steps. Just switch your x and your y and then systematically work through the operations, eliminating the cube root and the -5. So our function, our inverse function, is x cubed plus 5. Let's look at graphing that using transformations. We know, and this is my new f inverse function, so I'm going to graph it in blue. So we know that x cubed, we know that from memory and from our knowledge of the basic functions, that's going to look like this, curving upwards and curving downwards. And the plus 5 is going to move that graph up 5 units. So we come here to y equals 5, and we recreate this shape. So we go over 1, up 1, we go back 1 and down 1, and we know our basic shape is curved like this. And so this is the function f inverse of x. And notice that when I've graphed these two graphs, that they are a reflection across the line y equals x, as all inverse functions, graphs of inverse functions must be.